Hi guys, this is a computer vision project for Dr. Samuel Chang. It's our final presentation project. We named it the Live Barcode Reader. The teammates are Abel Arso. He's an electrical engineering student. He's originally from Ethiopia. He loves soccer. Fantastic electrical engineering student. Graduation date is in the fall of 18. Myself, Samuel Medina, studying computer engineering. I'm from Oklahoma City. I love cars. Um, I'm an okay electrical engineering student. Graduation is also in the fall. Our overview of the project, it'll cover the introduction, like how the UPC code came about, the problems we faced, and the problem that we attempted to solve. It covers a lot of the analysis and the approaches of what we had to do to come up with a good end result. So, what is a UPC code? It started back in 1973. An IBM engineer named George Laurer. He was studying how to help food processing companies and stuff market their products in a more manageable time frame. So think about this: they've got a huge inventory of the same thing, or they can have a huge inventory of a lot of different things. The problem is that they need some kind of coding scheme to be able to keep track of everything. So anyways, this is the structure. It starts out with 95 characters. They're all evenly spaced throughout. Um, they read opposite binary, which means what we would normally consider 0 being white is actually read as black, and what is considered white will read as a 1, or vice versa. So the reason why they do this is because laser scans, they always read better reading the absence of light rather than reading the light itself. So it's the way they figured out it was more ideal. So anyways, it's divided into 12 sections. There's 6 evenly spaced characters here, and then 6 evenly spaced characters here. There's a left side and a right side, and it's coded differently. The benefit that they have of this is that, when you're scanning something at the POS, or point of sale, that most grocery stores employ, they have to be able to scan them very quickly. Time is money. They're having to pay the associate to work there and stuff. So the more he can produce in a set amount of time, the more profit the company has to send them off to go sweep floors or something. So anyways, there's 2 guard sections. There's a left and a right guard section, which are here in the middle. There's the center section, and then the left guard section's here and the right guard section's there. The benefit of this is that it allows the barcode to be oriented in the fashion that it needs to be. So you can even scan it upside down if need be. It'll still pick it up because it's set up that way to let it know where the center and the guard band is. Another benefit with this is that the left side and the right side are coded differently. So what that does is, if you'll notice, all of the left side starts with the 0 and ends with a 1. The opposite happens with the right side, where it starts with the 1 and ends with the 0. Again, helping orient the scanner to let it know, hey, the barcode's upside down, so fix it. So those are really good. It reads from left to right. It's always been, it was an American tradition. If it had been maybe in different parts of the world, it'd be from right to left, but who knows? So anyways, we continue on. We talk about what the 95 sections read. They read individually a number based on the distances between them, and it's in binary. It's like what every other computer code is based off of, you know? So it's all basic, fundamental stuff to make it quick, fast, and efficient, cheap, everything. The whole nine yards, making everything really good. So after all of this, we need to be able to not only produce a code, but keep track of the code itself. So let's say, for instance, there's a different company that wants to make the same thing or wants to make a different thing or whatever, but it's like they need to be able to use their codes that are relevant to themselves. So let's say, for instance, Campbell Soup wants to make a soup, but the competitor wants to make a soup as well, and they want to be able to stay stocked on the same shelf. Well, the store isn't going to take the other company's barcodes and stuff unless they match their codes. So what they had to come up with was a scheming setup so it would let it know, hey, this code scheme matches this particular product or manufacturer or what type it is. See, that's another thing that came up. Not only could the barcode be used for the actual products, but they also used it for weighted items, for pharmaceutical items, for coupons, stuff like that. Things that you would cover, you know, that are in the store that aren't necessarily the product, you know, behind them and stuff. So, anyways, this is known as the outside number here. That lets you know the type of what it is. The next six numbers are the manufacturer code, which again starts from 0, ends with a number 1 and stuff for error check, which is a really good benefit. And then the product code. It starts with a 1 and it ends with a 0. So different manufacturers have different codes, different products, so we'll have different product numbers and stuff. It's just the way of the world, you know? So anyways, after all of this is done, they still had to come up with a foolproof setup so it would not fail, you know, reading the code. Not only would it pick up the numbers, translate them, emulate them into binary, and then come out with the number, it also needed to let it know, hey, did you do this correctly? So that's when the modulo check number comes in, which is this one right here. It's at the end. The benefit of using this number is that it's a foolproof way of letting it know it read the barcode correctly. So the way it works is it multiplies the manufacturer code, which is in all odd numbers or whatever. So it reads all of the odd numbers and it multiplies them by 3. Then it adds all the even numbers and it comes out with a total value. Now the way it does this number is it rounds it off to the next highest 10th digit. So for instance, this one's 23, it'll round off to 30, and you subtract 30 minus 23, you come out with 7. And that's how it knows, hey, we did this correctly. Cool, we can move on, right? So now, understanding our problem. Well, we're trying to simplify this process using, you know, what we have available to us. Most of the barcodes are unreadable by the human eye. We can't, you know, specifically separate, you know, the lines from the ones and zeros. So we need to have some form of reader to do it for us. So that was our first problem. The next problem is that they were too long. You know, 12 digits. The average person only remembers 2, at best 4, maybe even 6 digits. Think about it. Phone numbers, social security numbers, any numbers that are relevant to human memory, they always tie them at maximum 4 digits. And the reason why they do that is you're more than likely to remember them. The computers, it's okay. They can go as long, they can span billions of numbers long, and it's okay. So the next thing is expensive hardware. The point of sales at the stores cost anywhere from, you know, I don't know, they're thousands of dollars and stuff. Honestly, I think at some point they said that if you were to steal something from the store, you'd always be better off stealing their hardware than you would be the products they're selling. And it's true. It tends to be very expensive. The first systems used a laser guided setup. That laser gun was very expensive. It needed to be able to radiate it into a line instead of a dot. And so they had to come up with ways how to do that. The point of sale was a real hardcore computer and needed, and computers were very big and clunky at that time. And so, we needed to have something that we would be able to go around the expense of new hardware. And the last thing is that it was time consuming. Having to punch in the numbers and stuff as, as we students are so busy and stuff, by just taking a picture versus typing them in, man, it just walks worlds around it. It's really fast and efficient. So our project objectives for this setup was that we needed to simplify the process. How can we do this to where we don't have to use a lot of very complicated algorithms, or you don't have to require a whole expensive tool set of things to be able to make it work? No, we wanted to be able to use existing hardware. It needed to be flexible and improve accuracy. So what we're referring to this is that, hey, most engineering students, we have a laptop, and most laptops nowadays come with a webcam, and we can go through there. That would be the best way because it would improve the likelihood of having a successful solution to our problem if the people that are using it are, the normal day-to-day users and stuff. So if we could simplify the process, that would be great. So just, there's nothing easier than just putting something up close to the webcam and having it snap a picture for you. That's great. Using the existing hardware, not having to go out and spend thousands of dollars on something that you're only going to use a couple of times a year, maybe, or if you have a business, it would be for more than that. We needed it flexible. You could carry around your laptop everywhere. That's fine. You don't have to leave it stationed in a particular place, which is in some cases more efficient than the point of sales at the stores and stuff. So, that from there, and then improving accuracy. Well, we'll cover more of that on the later slides and stuff because it ended up being more of a hassle than what we thought it would be. So, improving the accuracy, not only did we need to be able to take the picture, but we needed to know what it was, right? The very first beginning steps and stuff was to find out how are we going to even make this feasible. So we started off with the image of the barcode. The barcode is being read and stuff using a regular webcam, which more than likely is only a couple of megapixels in size, where nowadays, the LED screens have gotten thinner and thinner and smaller. The drawback and the loss with that is, hey, you have to be able to fit in a smaller webcam, a smaller setup and stuff, which means they're going to compromise with quality. So it's not a very good setup, it'll read video, it'll capture the image. So that's the way we did it. We ended up using what we had been using throughout most of our college careers, which was MATLAB and stuff, and built-in hardware like the webcam from the screen and stuff. So, and talking more on MATLAB, it's really good at setup. It's multi-paradigm numerical computing environment, which in non-STEM programs, this means it is awesome because you can simulate things that you would be otherwise have to produce in the real world and stuff, which can at times be numerical. It can be signal based. It's pretty cool. It was all developed by, well, not all of it, but the guy that started everything was Cleve Muller. He was from the University of New Mexico. He was a chairman of the computer science department that needed to help solve problems for the engineering department and the STEM program and stuff. It's like, well, we already have coding and stuff, and it's like we need something that'll cater more to our needs. So that's what they ended up doing, and it's been pretty good. You can compile the program and put it into regular chips even. So you can export it. It's very versatile and stuff. So that leaves us to making it more flexible, using the existing hardware back again to where we were at and stuff.
Hey, my name is Abel Ararso. As my friend mentioned that we decided to use a web camera. We have two kinds of web camera, built-in external web camera, but we decided to use a built-in web camera because it's already built in on our laptop that won't cost us any money. After we used the web camera to take our picture, we had trouble with MATLAB because the image we took wasn't really great to compile in MATLAB because of unnecessary noise, and we had a trouble with image processing because our picture wasn't clear enough. Also, the image we took was the entire soda can, which is we don't need. We only want this area of the barcode. The unnecessary noise was happening because of the light reflection. When we get close to the web camera, the soda can will reflect the light into my laptop, and that caused a lot of noises. Also, the shade happens because when I put the soda can up to take the image, it will cover the light that will create the shade on my laptop. We also had really hard time with that one. Also, the brightness or the darkness of the atmosphere matter. If we take a picture on really bright, that will have more lighter reflection, will show us on the image. If we take it dark, it won't be. We'll have less light reflection, but the image won't be clear as we need it. Web camera quality also really matters because when I took this image, the soda can in my laptop, and when I ran through the code, I wasn't able to do it. But it works really great on my partner laptop, better than my laptop. We tried to reduce the noise by shrinking the image. So if we zoom it in, we can able to see better barcode. We got equalized the image. Grayscale image command was really helpful in MATLAB to do reducing the noise, also to work on our image processing. On the image processing part, we use a grayscale to convert the image from white to darker, and we remove the background unnecessary that other than the barcode area, like the table, the calorie stuff, which is we don't need them, so we try to increase those areas. Sober edge detector was very helpful to read the vertical and the horizontal line. It will automatically will do that for you, the edge detection, vertical and horizontal line. But we run on a big problem because the sober edge detecting only was detecting the vertical edge, but not the horizontal edge. But we were able to come with a solution to do manual edge detecting instead of letting the sober edge detecting do it automatically. The first step was we find horizontal space, which is we don't need, like when we do the horizontal lane, as you can see, the barcode is a vertical, so we can get the horizontal and we can remove them. On the second step, we focus on the vertical line, which is we need the barcode. Still we have some vertical, but it's less than the horizontal. After that, after we did the vertical and horizontal, we intersect the region, and we were able to remove we are able to remove the background because the horizontal wasn't needed. We just removed the entire horizontal layer. After that, we identify each region using a color schematic, so it will be better for MATLAB to see this than the previous image. Finally, we took the largest piece of regional volume. As you can see, the darker and the white one is the barcode that we're going to focus on. We took the Hoji to convert the image in order to shade the output image, like it shows right here. We just got it. We remove all the background, those unnecessary noises. Now we're left with the barcode. The result wasn't perfect as we expected because of the noise, the reflection, and where we took the pictures really matters. But however, on this run on the Surakin, we were able to get the result out because we had bigger region was detected by manual detection. Thank you.